Perfect. Hello to everyone. Thank you to coming here to this new webinar. Our panelist from today is Mr. Craven Jones. So let's start. Mr. Craven, can you please go ahead?
Yeah. So yeah, thank you for the invitation to present. So I thought I'd go through a little bit on the Invertek product range that we have available and answer any questions that anybody has. So just feel free to stop me if you've got any questions. So my position is I'm the global application support manager. I'm the training manager for Invertek Drives based out of the UK. The company's in the UK, but I'm actually based in Brisbane, Australia. So I cover the whole, mostly the Asia Pacific region and the Americas. So we'll jump right in. So with the Invertek product range, we have three main family of drives. We have the OptiDrive E3, is our general purpose entry-level product. We have the OptiDrive P2, which is our performance drive, and the OptiDrive Eco, which is our pump and fan drive. We also have some application-specific products as well, the OptiDrive Elevator, but that is access only for like elevator OEMs or elevator specialist companies. But we also have a growing market as well in the solar pumping. So we have a version of the P2 where we can feed directly with power from solar panels from a solar array. So some of the typical applications that we have, I've put together a little matrix. So the most common application for any for any drive is pump and fan. So around 80% of the drives in the world are used on pump and fan applications. So I created this little matrix here. It's just like a traffic light system. So green means yes, the drive is perfectly suited. Amber or yellow could mean that we have a product that's better suited, and then red means the product is not suitable for that application. So when we look at pump and fan, the biggest application areas for VFDs, our E3 product is ideally suited for that application, and our Eco is specifically designed for the pump, fan, or the HVAC type market. It doesn't mean that we can't do pump and fan with a P2. We can, but the Eco is designed for that space. Conveyor applications also, that's another huge area for VFD applications. And the E3 and the P2 are ideal for those, but the Eco is not suitable for like conveyor, those kind of constant torque type applications. Mixer application is another application area where we have great success. So mixers come from all different kinds of markets. So we have obviously the food and beverage market. We have things like chemical mixers, paint mixers, anything that actually mixes different mediums together. And again, the P2 and the E3 are the ideal applications for that, or products for that application. The compressor market is also a huge application area. The E3, P2, and the Eco, all three of them can do that quite happily. The crane market, so we have two main applications in cranes. That's the trolley or the travel, the long travel, cross travel, and that's ideally suited for the E3 and the P2. And then we have hoisting. The P2 is designed and has special features in it for crane hoisting. So if you have any applications with hoisting, whether that be a normal crane or a winch type application for marine, then the P2 is the ideal product for that. We also do a lot in mineral processing, so crushers, for example. The P2 is the main product that we use in that, purely because of the size of the applications. So they're usually well over 37 kilowatt or 50 horsepower, and that's the power limit for the E3. So winder and unwinder applications, so things like web tension, so wire drawing, those kind of applications, the P2 is the product that we have for that application as well. A growing market for us is centrifuge. So we can use the P2 and the E3 together on those applications, because normally you have one bigger drive and one smaller drive. And then press applications. So we have all different kinds of press applications, but again, they're usually on the higher end of the power range. So the P2 is the main product, but when we look at a lot of recycling plants and things like that, they have like cardboard presses for making waste cardboard into bales. Then the power is usually a little bit smaller on those, so it could be a good suit with the E3 drive. We also do a lot of washing machines, so industrial washing machines, not the little ones that you have at home. So these are applications which have very, very high inertia, but we are very successful in doing that with the E3 or the P2. And then obviously this is just a small overview of some of the typical applications that we do. We do a lot more than this, but the final one on the list there is extruder. And when we talk about extrusion, a lot of people think about aluminium extrusion or plastic extrusion, and that's where we use the P2. But there's also a growing market in extrusion for animal feed. So things like agricultural application for like chicken feed, cow feed, things like that, where they make pellets, so pelletizers, those kind of applications. They're also an extrusion application. So that's just a brief overview of some of the typical applications that we deal with. Any questions on that? If not, then I'll move on. So just going to go with an overview of the individual product families now. So the E3, this is our easy to use entry-level product, so general purpose, with a power range from 0.37 kilowatt up to 37 kilowatts, so half a horsepower up to 50 horsepower. We have several different supply options, so everything from single phase 110 all the way up to three phase 480. So we can do single phase or three phase input. And we have two enclosure types. There's the IP20, which is supposed to go into a control cabinet, and an IP66 unit, which doesn't need to be in an enclosure at all. Even though this is our entry-level product, we can still control induction motors, brushless DC motors, permanent magnet motors, and synchronous reluctance motors also. So this means that we can control all the high efficiency IE4 and IE5 motors just with our entry-level product. And it's a very easy setup for these. Now, in the E3 family, we have the IP66, so washdown ready for things like food and beverage, but it's also outdoor rated. which means that the case of the drive is actually UV stabilized. So it's dust tight, so we can use it just about anywhere. The only thing I do suggest is not to put it in direct sunlight, not because of the UV issues, but because of the heating. So put it in the shade. Or we have the IP20, the IP20 drives, which go into control panels. Now the IP20, that goes up to 37 kilowatt or 50 horsepower. And our design is focused on ease of use, being compact and very robust. So we put the design philosophy for Invertek has always been make it easy to use. So with the IP66, we have the similar interface. So we've got the same display and the control panel on the drive, whether it's IP66 or the IP20. The IP66 itself goes up to 22 kilowatts, so 30 horsepower. And again, ease of use, compact and robust, but also, in addition, it's outdoor rated. In each of these products, we have an internal EMC filter, so that we don't have problems with electrical noise. We have an internal PI controller, so we can do pressure systems, temperature systems like that inside the drive rather than having to have an external controller. We also have an internal brake chopper, so if an application needs to stop quickly with high inertia, then we can do that also. We've got 2 analog inputs on these drives. We can operate up to 50 degrees C with the IP20 drive. So that means that our excuse me, our cabinets that we put the drives in require less cooling than it would if it was a 40 degree. We've got Bluetooth connectivity with the drives. So we've got a little module we can plug into the communication port on the drive, and we can connect directly to the laptop with OptiTools. And as part of the reliability of these drives, we also use long life components. So there's only 2 components in VFDs that go over time, and that is usually the DC bus capacitors, because that's their nature, you know, and the cooling fans, because they are obviously rotating machines. So we have a specification that our component suppliers have to reach, a minimum of 50,000 hours. So we have also preventative maintenance plans and those kind of things for the drives to help to keep the lifetime as long as possible. And we also have an inbuilt energy optimizer that can be turned on or off depending on the application. In the drive itself, we have 3 modes. We have an industrial mode, so that is designed for constant torque applications like conveyors, mixers, treadmills, those kind of applications. We have pump mode, so for dosing pumps, borehole pumps, transfer pumps, those kind of applications. We do a lot of decorative fountains and things like that with the E3. And then we have fan mode, so air handling units, ventilation fans, circulating fans, air curtains, and we have quite a high install base, or quite a large install base of kitchen extraction with these also. So the industrial extraction units for industrial kitchens. And to choose this mode is very, very simple. It's just 1 parameter, and then that sets some preset defaults in the drive that are ideally suited for the 3 different modes. Excuse me. So industrial mode, So it's optimized for load characteristics of constant torque applications, so typical industrial type applications. We have an exceptionally good sensorless vector control algorithm in the drive, which gives us good high starting torque for starting loaded conveyors, for example, and excellent speed regulation if we have load changes on the application. And of course, the firmware is common for the IP20 or the IP66 units. We can also use the OptiStick Smart, so the Bluetooth interface, as a parameter copying function as well, a parameter cloning function. So if you've got an OEM that does the same thing, the same function with drives multiple times, then they can have one setup in the OptiStick and just download it to the drive very, very quickly. We have pump mode. So we can use pump mode with constant torque or variable torque pumps. So constant torque pump would be typically like a rod pump or a positive displacement pump, whereas variable torque pump is classically a centrifugal pump. We've got an internal PI controller, so we can actually feed signal directly from a pressure transducer or a flow transducer and get the drive to automatically regulate around a desired pressure, flow, or temperature, whatever value you need. In fan mode, we also have, in addition to the internal PI controller, we've also got flying start capability. So with fans, even when the fans are turned off, if there's airflow in the air ducts, then they can actually push the fan to run in the opposite direction. So what we do, we can actually synchronize with an already spinning fan and slow it down or speed it up or change direction, whatever is needed, so that we don't have a big mechanical shock when we try and start it from zero. We've also got very good mains loss ride through. So if you get a dip in the mains, then the drive remains powered because the fan will actually turn into a generator and push power back into the drive. So that helps to keep the drive powered up in short-term mains loss type situations. We've also got fire mode in the drive as well. So if we're using it for, we can use it for smoke extraction type applications, so that if the drive gets a signal to say that it needs to be in fire mode, then it just ignores non-critical trips and will just keep on running as long as it can. So that was just a brief overview of the E3. I'm just going to move on to the Eco. So the Eco, we actually go from 0.75 up to 250 kilowatt. We've got the IP20 unit, the IP66, and we've also got on the larger units IP55 also. So designed for energy efficiency. So pumping, fan control, compressor control, those kind of applications where energy efficiency is key. So we have reduced harmonic distortion with the Eco drives so that we can comply with EN 61000-3-12. Are there any questions yet?
No.
No. Okay. Yeah, so we comply with the with the relevant standards for harmonics. So specifically 61000-3-12, that is for public low voltage power systems. And that covers VFDs with phase currents of between 16 and 75 amps. So we have the declaration of conformity available, so you can just download that if you need it for project documentation, for example. We also run with a higher input power factor, so that helps to improve the efficiency of the overall system. Again, we can control all the different efficiency class motors, so the IE2, IE3, IE4, and IE5. So, excuse me. And with the Eco, we have exceptionally good motor control performance, specifically designed to give us the maximum amount of energy efficiency. We've also got dedicated pump control features in the drives. So pump dry running, loss of prime, those kind of situations. We've also got a load monitor so that we can monitor the current going to the pump and detect if it's becoming clogged, or if there's going to be a jam type situation, and we can actually carry out a cleaning function in those kind of situations. We've also got inbuilt into the drive a function block editor, so we can actually customize, or the firmware is more customizable for OEMs which have specific functionality. We can also display real units on the display of the drive, so bar, PSI, degree C, parts per million, those kind of units that are normally seen in the industrial areas or in the industrial markets where these drives are used. So as I said, it goes up to 250 kilowatt. We've recently launched a new frame size 8 drive, the biggest drive. Instead of going up to 350 kilowatt, 350 horsepower, it actually goes up to 400 horsepower. So again, every time with the Invertek products, it's focus on ease of use. We want the customer to be up and running very nice and quickly and easily. So we make it as easy as possible to commission, to interface with the drive. We've got, as I mentioned, dedicated pump control features in there, as well as BACnet and Modbus RTU on board as standard. We can do cascade pump control, dry run protection, pump cleaning, and also pump stir functionality as well. So because we have the PID loop in the drive, where we can feed a transducer directly back to the drive, we've also got a sleep function in there. So with things like booster pump type applications, where the drive can actually be in a standby situation for quite a long time, when there's no demand on the system, it automatically goes into standby mode, so that it's not burning energy for no reason. Then if it's in that standby mode for a long time, then we can use the pump stir function just to stir up the water in the pump, so we don't have problems with sediment settling on the pump impeller. We've also got a motor preheat function available in the drive as well for like cold room type applications, so refrigeration, where we can preheat the motor before we start. So this is to help to stop condensation buildup in the motor, which can be problematic. So the frame sizes, we go from frame size 2 to frame size 8, and we have several, we have 3 different IP classes. So IP20 for drives mounted into control cabinets, IP55 for the bigger units, so we can mount them directly on a plant room wall or something like that. And then we've also got the outdoor rated IP66 units. We have a very wide selection of supply voltages to match the global markets. So up to, excuse me, up to 2.2 kilowatt, we've got single phase input, 3-phase output. This is actually in the process of being extended up to 7.5 kilowatt. We've got 3-phase 230-volt input. So you find that quite a lot in the Americas and some countries in the Far East. We've got the standard 380, 480, where you that's pretty much an industry standard globally. We've also got 525 ratings and 600 volt rating. The 600 volt is specifically for Canada, but we have them available for OEMs that export. So the IP20, as I mentioned earlier, we've got a new frame size 8, which is also available on IP20, and that's designed to be mounted into a control panel, and these are fan-cooled units. So the space required to keep the airflow in the cabinet is in the manual. It's very simple. Just have a space above and below the unit just to make sure that the airflow is not blocked, just for cooling. The IP66, again, outdoor rated, so it's a wall mounted design. We can have it with or without an isolator. And these are convection cooled, so there's no heatsink fan on these. Then we have the IP55, again, wall mounted type units, and they are fan cooled. So you have heatsink fans on the unit to push the air through to keep the units cool while they're running under load. We can have several drives working together to do booster pump applications. So duty assist, duty standby, duty assist standby, jockey pump type applications. So we can have self-contained systems just with feeding back a pressure signal to one drive, and then it controls the others. And in the configuration that we have with OptiFlow, that's our own proprietary control algorithm for booster pump sets. If one of these motors is taken offline, say for maintenance or something like that, then another one will automatically take over. You can even turn off the main power to the master drive, the main drive, and another one will automatically just take over. So there's a huge amount of redundancy built in here to give your customers peace of mind. So we can also rotate the run times on these pumps to keep the run time as close together as possible, so that if you go to site to do maintenance, excuse me, you can set the drives so that they never have a runtime difference greater than 24 hours. So it makes it really nice and simple. So you can go in, do maintenance on all of the drives at one time, or all of the motors all of the pumps in one visit, sorry, rather than having to go back and forth. So there's an example of a duty assist standby system that we actually did here in Brisbane with one of our pump OEMs. So they have a pressure transducer coming from the system into the drive. Then we connect the drives together just with an RJ45 cable, and they work together to ensure that there's always system pressure available. This was in a residential high-rise block of flats or apartments. So if there's low demand, if everybody's out at work, for example, then maybe just one of the pumps will be running. If they need full system pressure, then two of them will be running, and the third one is always in a standby type mode. So as you can see, with the way we mounted these IP66 units, we just mounted them directly onto the motors, and that means that the cabinet here only has the 3 circuit breakers, one for each of the drives. Everything else is self-contained in the drives. Any questions on the Eco? If not, we're just
Sorry,
going to move on. No, sorry, yes?
sorry for the interruption. Just to let uh, know to all our attendants, they can open your microphone to ask a question well, if you are on a
Okay.
computer or mobile device, you can find an option called question or chat,
Yeah,
which you can write all the questions and well, we will gladly answer them.
yeah,
That's only that one announce. Sorry.
that's fine. Okay. Yeah, we can, we'll continue with the P2. So just check there's nothing on the chat there. So the P2, we have the same power range as the Eco, so 0.75 to 250 kilowatt, and in IP20, IP66, and IP55 units. The P2 has a focus on industrial performance type applications. So we have safe torque off built in standard. So that's safe torque off to SIL2 performance level D. And it just makes it nice and easy for OEMs and machine builders to integrate it into existing safety systems. So anywhere in the plant that needs light gates, things like that. So if you open the gate or if you cross the barrier, then the drive will automatically stop. So that's built in as standard on the P2. We have a dedicated hoist mode. So hoist mode is just selected by a single parameter, makes it very nice and easy to safely commission a crane very quickly, or a hoist application. We can also do hoisting applications open loop, so we don't need an encoder like most of our competitors do. Since I've been working with Invertek, I've only done, I think, 2 hoists where there were encoders on them, and that's only because the customer insisted that the encoder was there. But we do not need an encoder to do hoisting with our drives. So that can, obviously an encoder can also be a failure point because they're quite delicate devices in an industrial environment, so that can be a real benefit. We've also got an application note for hoist mode already done for to help you. It's a step-by-step guide on how to commission the P2 for hoisting applications. So you can get that from Sumitomo. They can just send that out to you if you're doing a crane commissioning. It really makes a big difference and helps people to not only commission it safely but quickly as well. We've also got built-in master slave, so you can connect multiple drives together. So you have one master, and you can have several slaves if you need to. So if you've got things like, an application like conveyors, where you have an in-feed conveyor which has to be feeding into a main conveyor, an out-feed conveyor, or a batching conveyor, we can actually scale the speeds of the different slaves on the system. So if you need a faster speed for the in-feed conveyor or a slower speed for the out-feed conveyor, then that's easily done in the drives. We can also do load sharing applications. So like mining applications where you have multiple motors on the same conveyor, like head end, tail end type applications, where we can actually load share between the two drives and motors. With the master slave control, you can also do inlet and extractor fan airflow balancing very nice and easily. So you don't need to use external controllers for that. So carousel type applications where you have multiple motors working together. In master slave mode, it's very simple. We just connect the drives together. We use splitters for the RJ45 cables, but they're just standard RJ45 cables. All we do is open up the extended menus on the drives, and on the slaves, the address, so the drive address, P501, just has to be greater than 1 on the slaves. And then you tell the slave drives with the control mode that they're in slave mode. And all you have to do is enable the drives, and then they will follow exactly what the master tells them to do. Again, we have an application note available to help you set that up very easily, very quickly. We can also do PID control for P2. So we can use that on pressure control, temperature control, or on things like winding tension control applications, where you need to keep a tension on a winder, unwinder, or a wire drawing type application, paper machines. So we can actually give the driver feedback signal, whether that's a pressure signal, temperature signal, speed signal, like meters per minute or feet per second. And then we can automatically control the tension on these kind of applications. We've also got the energy optimizer in the P2. So depending on the type of application you're using the drive for, you can turn it on or off. In the Eco drive, it's always on because that's specifically designed for quadratic or variable torque applications. But in the P2, you can switch it on or off as needed. And what it does, it monitors the output to the motor and the load, and then where possible, it'll reduce the motor voltage in proportion to the load. So you keep a constant speed, it's just you can save more energy, even on constant torque applications. The main energy saving for any VFD application is where you're running a pump or a fan on a partial load. And that's because of the nature of the actual load itself. We have very accurate torque control on the P2. In most applications where we're in speed control, but we need good breakaway torque to get the motor moving, to get the load moving, things like extruders or mixers or conveyors, or in hoisting applications where we need to hold the load against gravity. We have very, very good low speed torque availability on these drives. In other applications, so winding tension, vacuum pumps, we have very good torque control mode there where we tell the drive you need to stay at this level of torque on this, or you need to keep this level of torque on this motor. But we also have a shear pin torque limit. So instead of using a mechanical shear pin in a gearbox, we can do a shear pin torque limit in the drive electronically. So again, that's a brief overview of the P2 drive and the main applications. But as I mentioned at the beginning, we also have a solar pump drive available as well, which is a P2 drive just with different firmware in it. So, excuse me, the P2 solar pump drive, everybody depends on water. No matter where you are in the world, you always need water. And a lot of the technological advancements in history have been getting access to water. or transported water. So what we have now in the current technology is it makes it possible to power these pumping stations or pumps directly from photovoltaic generators, so solar panels. We do a lot of applications for pumping groundwater from quite deep wells, anything from 10 meters down to 500 meters, as well as surface water type applications. So anywhere remote where there's not an easy connection to the mains, the power grid, then we can use solar panels to supply power to the drives. We can do this with the E3 as standard, so it's an ideal solution for a low cost general purpose type solution. So instead of feeding the mains powered into terminals L1 and L2 on the drive, you actually feed plus minus DC from your solar array. The drive itself looks at the voltage coming in from the array and then regulates the pumping, sorry, the speed of the pump to the available voltage on the DC bus. And it's a pretty good simple solution for most general purpose type pumping applications. It's a very good viable solution for low cost solar pumping. But we also have a high performance solution in the P2 solar pump drive. We have special firmware in the drive which uses a very efficient or highly efficient maximum power point tracking algorithm. So MPPT, anybody who deals with solar pumping will have heard the acronym MPPT, so it's maximum power point tracking. It gives significantly higher levels of pumping than just using an E3 in PI mode. So this is because it actually monitors the current conditions for the like if there's clouds in the sky, what time of day it is. It monitors the actual power coming in from the solar array and regulates the pump speed much more accurately so that it utilizes as much of the power available. So we have quite a lot of these applications in the more remote areas. Like here in Australia, obviously we have a lot of sun and a lot of space. So there's a lot of solar pumping applications. We do a lot as well in, we've done quite a few in South America. You can go onto the Invertek website and find some application cases or application stories there for those. But it's good to know that we have the product available if you have these kind of applications. So, but throughout the whole of the product range, whether it's the E3, P2, the Eco, or even the solar pump application, we do have one of the world's best open loop control systems. Because again, we can control all the different motor types, so induction motors, permanent magnet or synchronous machines, brushless DC machines, synchronous reluctance, and we are completely manufacturer independent. So it doesn't matter who makes the motor, we can control it. So yeah, that was what I was going to go through. Is there any questions?
Carrie, any chance we're gonna go into some selections of the VFDs?
selection of the VFDs for the different applications, or?
Yeah.
Yeah.
In case they are not clear how to select the right model of the VFDs.
Oh, okay, yeah, that's the, I'll just, hang on, that's the, oops, sorry, that one. This is a quick way of showing that.
No. According if they have a nameplate of a motor and they're gonna select a VFD.
Oh, sorry, I see what you mean.
Important things they need to know.
Yeah, the motor rated current. You should always select the drive for the motor rated current. So let me pull up a picture of a, oops, let me pull up a picture of a motor rating plate to give you an example. Where have I got? Yeah, so if we look at a standard motor rating plate, 2 seconds, I'm just pulling up that picture. There we go. So if we look at a standard motor rating plate, the most important is the motor rated current. So obviously your supply voltage, wherever you are, whether it's a 230 volt, 400 volt, or if you've got a 60 hertz system, a 265 or 460, you look at the motor rated current, and then you choose the drive that can give you that current and the overload that's needed from the customer. So in this case, if I'll just open up the brochure just to show you a very simple, quick way of choosing it. Let's do the E3. So if we look at this one as an example, so if you've got a 460 volt system and 4.3 amp, in the product catalog, you've got all the features of the drives here, and there's the ratings. So I'll zoom in on that. So we've got 460 volt, 4.3 amp. So there's the 380 to 480 volt drive. So 4.1 amp is too small, so it's going to be a 5.8 amp. It's as simple as that to choose these drives. And then depending where you're going to be mounting the drive, you're going to be using an IP66 or an IP21 or an IP20. So if it's going into a control cabinet, you'd select the IP20. And if you're going to machine mount it or wall mount it, we've got two options. We've got one with the control, so that's a potentiometer, 3-position switch and an isolator, or one with none of those on. So all depends on what you need for your application. What's the typical 3-phase voltages that you have in your region?
Okay, in Gavin, if you can tell us what is your typical voltage, frequency, current of the motor that you use in Jamaica. And Selwyn, if you can tell me in Guyana what is the typical voltage and also frequency and current of the motor that you're using in Guyana.
$220 volt 50 hertz and 440 volts 50 hertz in Jamaica. Excellent.
Uh-huh.
Yep. because like with these, like with the Lefert motors, it's nice and simple. You have just a few ratings on there. These are just the parameter numbers that we put them in on the drive. But with some other motor manufacturers, you can have a lot more information on there. So if we look at Jamaica, for example, that's 440 volt, 50 hertz. So here, that's 440 volt, 60 hertz, or we can use the 415 50 hertz. Either's fine. All we have to do is make sure we choose the closest one we've got there, and then the current rating for the drive. So if we think about this one here, we've got 440 volt. I know it's 60 hertz, but that's just the speed. We can sort that out easily enough. 440 volt, 59 amp. So we just go into the brochure. This is the 400 volt range drive. So it covers from 380 all the way up to 480. And there's 30 kilowatt or a 61 amp drive. So 61 amp all the way up to 480. That's no problems there. Like here, there's 59 amp, but it says it's 35 kilowatt. This is why I always tell people size the drive on the motor rated current, because the current is a real number, the kilowatts are calculated. So here you could easily, in this situation, if your customer says, oh, I've got a 35 kilowatt motor, a lot of people would just go and choose a 37 kilowatt drive. I ask the customer, what's your motor current? And he says 59 amps. So here then, I've actually gone down the size. I've gone down one size because this drive, even though it says 30 kilowatt, can give 61 amps. So that means that I could be cheaper than the competitor. So this is why it's so important to use the motor rated current, not the kilowatts or the horsepower. Is that clear? Yeah. So, and of course, the higher the voltage, the lower the current per kilowatt. So you can really get, you can see here, a 380 volt, 30 kilowatt is 59 amp, 400 volt, 30 kilowatt, 56. 415 is what we have here in Australia, that's 54 amp. So these are the real numbers, these are calculated numbers. So always use the real numbers. So again, back here, it's nice and simple. You've got two choices there, 50 or 60 hertz, and two choices in each. So for this case, we've got 2.2 kilowatt, 230 volt, 8.3 amps. We go single phase in, 220 volt or 200 volt up to 240. Then we've got the drive there that can do 10.5 amps, so that's big enough. If you've got a three-phase 400 volt system, then you've got the ratings here. So
I have another question here.
Yeah.
What about if we have a single phase voltage in the supply, in the source, and we have a three-phase motor?
Well, for single phase 200 volt or 200 to 240 volt, we have drives which can take a single phase input and give you a three-phase output. So that goes up to 15.3 amps. So that's no problems at all. We have that possibility already. If it's bigger than this, say in some countries they do have like a 480 volt single phase. We can use a 3-phase 480 volt drive, but we derate it by 50%. So it's possible to do that, and we actually have an application note to give you the details on that if you need to do that. But single phase to 3-phase, it's not a problem on 200 volt or the 220 volt. Typically, what are the biggest the biggest ones that you'd need to do that on? Because for most countries, 4 kilowatts single phase in and 3-phase out is quite big. But if you have higher than that, we can do it with the eco. I'm just looking for the details right now. Because we increased the range from 4 kilowatt up to, I think it's 7.5 kilowatt now. So do you have a lot of single phase to 3-phase applications?
We have people asking about that application in some residential complex.
Okay, yes, yeah. Yeah, what we can do there, we can go to the Invertek Drives.com website. We go to variable speed drives. So if we look at like a pumping application, for example, so a domestic type pumping application, we've actually got a drive configurator here. So if we click on the configurator, so we can see, let's choose the motor amp. So this would probably be quite a small one if it's a residential. So let's say a 10.5 amp. Now the supply voltage, we've got single phase or 3-phase. So if it's single phase, then it gives you the enclosure type there. So it's IP20, IP66. There you go. There's your drive, and then you can get the data sheet like that. And it gives you all the details. So if we go back, we'll start another one. So if we select the input voltage, single phase to 3-phase, then you can see we got, yeah, there you go, we go up to 10 horsepower, 7.5 kilowatt. So there we go. So there's your supply voltage, there's your input phases, there's your output ratings. So 7.5 kilowatt, 10 horsepower, output voltage, 0 to supply, and that's a 3-phase output. We can do the same thing with the others as well. We've got the configurator in the P2, the E3, and the Eco.
Okay. What are the benefits of the EMC filter?
Well, the EMC filter is just there to stop electrical noise, because any VFD, any drive on the market, any VFD on the market, because it switches semiconductors, it causes electrical noise. So you need a filter there to stop it, to stop any drive interfering with other electrical equipment in the system. So I see on the chat there, 15 horsepower is the biggest single phase in and 3-phase out unit that you'll need. So in that situation, you would, let's just do a quick one here. With a single phase input and 3-phase output, the biggest that we do standard is 10 horsepower. Most companies, most VFD manufacturers, the biggest they'll do is about 3 horsepower. We go up to 10 horsepower with the Eco. But what we can also do, we can, as I said, we can derate it. So what we would do there is we would use, for a 15 horsepower single phase supply with a 3-phase motor, we would use a 30 horsepower drive derated to 50%. So if we look here, there's the E3 is not big enough. Let me open up the E2 brochure. There we go. There's the P2 brochure. So if we need, sorry, too far. If we need a single phase, a single page view, that's better. So if we need single phase in and 3-phase out at 15 horsepower, in that kind of situation, we would just look at the 3-phase input drive and use the 30 horsepower. So as I said, we have application notes. Let me open up the application note for you on that. So this is an example, the use of 3-phase drives on a single phase power supply. So these are the ratings that we can do. And then a 50% derating must be applied to the output current of the drive. So there you go, there's the 3-phase rating, single phase rating. That's the input current and the output current available. So it's possible to do that up as high as 15 horsepower. Okay, is that okay for you?
Okay. Thank you very much, Mr. Jones, for that talk. I don't know if you can share an email in case of any of our attendants have any other question they would like to clarify.
Yeah, just send the questions through to Kaiser or one of the other Sumitomo guys, and then I'm happy to do it that way.
Perfect. Thank you very much. And well,
okay.
Thank you very much. And well, that's all for today. Thank you everyone for your assistance to see, well, your attendance to this webinar. And well, we see you in the next time. Thank you very much to all. Thank you very much, Mr. Jones and Kaiser, for the questions.
Yeah, I also want to say thank you to everyone to save the time for us, and I'm gonna send you an email with the brochure that you saw in the presentation. That way you can make the selection quick and easy. If you have any question, any other question, please send me an email. I'm gonna check with Carwin all your questions, your extra questions, and thank you again by having us today.
Yeah, I'll also send you a copy of the presentation so you can send that out.
Thank you very much.
Okay.
Well, then this is everything. Thank you very much. See you the next time. Goodbye.